So the flagship program, Big Data and Analytics, I really am trying to kill the flagship program term. Program manager was me, but I'm now looking for one. So anyone who's not quick enough stepping backwards, they might end up with the job. And basically it came about because members indicated a need to understand about information management and data analytics within their businesses. We went to an open expression of interest to the market just to see, you know, what innovations were out there that might help with those sort of tools. A couple of examples were identified, and I'll run through the trials that we ended up undertaking. We were shortlisted to 8. We then went back to them because we were trying to identify how are we actually going to choose what trials we're going to do. So we started by defining 2 problem statements. One was about data and therefore understanding data and how we might collect it and utilise it better within our businesses. And the other one was about insights. So, you know, what are the things that we can do with that data to actually make better decisions? And informing that was really what the whole purpose of the flagship Big Data and Analytics program was all about. So the first trial that we ended up undertaking, or is currently undertaking, and recognising that these trials are currently occurring, the GTS OSI Soft Pi software trial has just finished at the end of April with Lower Murray Water and East Gippsland Water. But the IBM trial, the Veolia IBM Waternamics tool at Western Water, and basically it's an operational based tool that's utilised for you know, pulling together data sets and data from lots of different sources and being able to display it in one purposeful place for visualisation and sharing of that information. So across sections of your business, from operations, customer interface, asset management. And the good part is that Dean's here today, Dean Barnett, and it's actually functioning outside of his office. So if you want to know anything about Waternamics and how it's running within Western Water, so the trial goes through until November this year. You know, he's a great one to talk to, and also Neil Brennan, obviously being within his business, he's right across it. So you can always catch up with those two to get a bit of an understanding of where Waternamics is at. The original solution designs were designed for Yarra Valley Water, Central Highlands Water and Western Water. So we set out with an allocation to do the preliminary design, and then from there we were looking at a business case to move ahead. So with the 2 initial, so Yarra Valley and Central Highlands, they got to a point and they said, well, actually for some other reasons that came up, Central Highlands couldn't continue on with it. Yarra Valley got to a point and said, look, you know, we don't know if we're going to go down this track. How about we use those funds to actually do a full implementation somewhere? And at that stage, Western Water were considering, we're working with Central Highlands Water about a joint, you know, let's go live type project. And unfortunately, some circumstances come up for Central Highlands that they couldn't continue on with that. But Western Water decided to go to the full implementation of the product within their business. So a big step, but in that time, certainly a large transformation within their business has been occurring, and it's actually helped, I think in a lot of ways, it's helped them think about their business and the way they're driving that. So the way that information moves within the business and how that actually helps improve the outcomes that you're achieving for your customers. At the same time as we've done that, we've developed a statewide model and licensing arrangement for IWN. So it sits under that. Anyone who's dealt with IBM understands a little bit about licensing arrangements, and that they can be quite complex. But we've managed to, you know, negotiate the way in which all of our IWN members can actually access this sandbox environment. So if you're keen to have a look at how Waternamics looks and feels, we can arrange that through this licensing arrangement. So it's the IWN sandbox. And there's a user manual that's been developed to go with that to help people guide through. But certainly the promotion, now that the product's been embedded for the last 4 to 5 months at Western Water, starting to do a lot more promotion about that, and some videos are being proposed, and we'll link that in also with the Lower Murray Water and East Gippsland Water trial. So what does Waterdynamics do? So it's effectively, as I talked about, a visualisation and data display in an operational environment. So sitting in the middle, you have your Waterdynamics tool. Linked in is your ETL at the base, which then transfers the data into the system. And that comes in from SCADA, from your laboratory information management systems, excuse me, your work order systems, GIS, and then can pull in data from other sources. So whether it be third-party APIs or from the Watson Bluemix IoT environment. So, and then within that, there's all this work going on in the background in IBM World that can enable further apps to be developed and then imported into Waterdynamics at a later date. But what it looks like is effectively, if you imagine you go into Google Maps and you can see on that all of your assets laid out. You've got your vehicles moving around so you know where they are. It's an operational centre effectively, and it enables the Western Water Operations Centre to interact directly with the customer and then talk about, okay, on there you can see not only the assets, but you can click on them and look at all the history in terms of you know, breaks, bursts, the like in that asset, in that actual location. If there's been water quality incidents, all those things come up in front of you, and you can turn layers on and off and utilise those to draw that all together. So it's a tool for drawing together data from multiple sources and enabling it to be in one place to make decisions quickly and at the end of the day, inform customers more effectively. So you can be on in this view and the customer says, yes, I've got this problem. You then click on the property and bang, it drops straight into Google Street View. And basically you can then say, oh, so is it that metre near the tree there? And they go, oh yeah, that's it, yeah. So the customer's getting this real-time connection with the person who's on the phone and trying to solve their issue. Same with when the operations centre is trying to send out a crew. They'll call up and they'll say, look, yeah, there's a big tree there, that sort of stuff. So suddenly the connection between what they're being told by the person who's taken the call and the incident and what they're doing to go and do in the field, there's that direct connection, and saves times, efficiency, direction of the vehicles. So you can start using the GPS location of the vehicles, mapping out the best, quickest routes, all those sorts of things. And then similarly with water quality, so you can see there that red square, water quality incident, okay, the SOP is automatically loaded into the system. So all your SOPs are backed up into Waterdynamics, and they become effectively, you know, step by step what that operator needs to do to go through and solve that issue. And it's all date stamped, recorded, all those things, so you've got a defensible position, particularly in the days of, you know, coroners' courts and the like. If something was significant to go wrong, you've got it all there recorded and installed in your system. So the whole idea being that it takes out that opportunity for human error, because they've just got to work through the process. It's there in front of them, and you embed your own SOPs into the system. So that's the Waterdynamics tool. And the other part that I didn't show, but there's a series of analytic tools that sit behind that as well. So you can start to collect your KPI data, ESC reporting, automate some of that. There's optimization tools in terms of your SOPs, the processes, and then obviously the value of the integration between your various systems. So the LSI Soft Pi, GTS undertook the trial, which is Green Technology Services. They proposed it, but so they're like effectively an establisher of the software in a business. So they'll come in and they'll work with the business to identify the use cases, and then do the implementation of Pi, with Pi just being the software product. So the trials were at East Gippsland Water and Lower Murray Water, and as I said, they've just been completed. So we're in the evaluation phase at the moment. So what did we learn out of it? What worked well? What didn't work so well? and what are the opportunities for the industry going forward. One of those has been a licensing arrangement with, like any software, licenses can always be the expensive part, but there's an opportunity for a collective license for IWN. Now they've given us some pricing that's based around population size, so that can impact on various, the larger businesses in terms of the cost factor that's involved. And what we've also found through this process is there is a couple of businesses in Victoria that are already using Pi in discrete parts of their business. But the opportunities that come out of the integration into the cloud means that we could actually automate some of our reporting requirements with DELP and others. And that's last week we had the DELP session on performance reporting and what we might be able to do into the future. I'm certainly been pushing that, it doesn't have to be Pi, but we have done a trial of this and this software works, and we've seen the opportunities that come out of it for the businesses. Maybe it's something we should look at, and I'm still trying to encourage that process to go forward. In the outset, there was a focus on a few key areas for the businesses identified by Lower Murray Water and East Gippsland Water. That was ESC KPI reporting. Could we develop something that automates that, pulls it in, makes linkages back to the existing systems? Water quality data, asset data displays and interrogation, so digital meters, pumps, various things that you're pulling data out of all the time out of your SCADA systems, but how are we actually utilising it to actually make better decisions? And so the whole purpose of Pi is being a data analytics tool and visualisation as well, but also there's opportunities for integration back into your GIS, and I'll show you a couple of examples of where that's happened. So this is just a sample dashboards, and the great part about Pi is they have this already established relationship with a lot of the energy industry, but also other water businesses around the world. So all the templates that they've created are pretty much available, and you just sort of drag and drop. And it makes it really simple in that you'll drag on a line of data and then you can layer across another line of data, and it doesn't matter where it comes from because it just drags it straight out. And then you can go, okay, well that looks okay as a graph, but how does it look as a run chart? So all the templates are already there, and you can actually just display them and use it to actually just explore the data. And I think that's what we've been lacking as businesses is we're really good at collecting data, but when do we actually get in and explore it and just play with it and look for those things that could actually tell us something meaningful about our businesses? And so in this instance, this is just a simple runtime. The green would be telling you if it's working or it's not working, so it'd be green or red. You just have it as a dashboard sitting in your operations centre. The number of revs per minute, all those sorts of things, which pumps are operating, the trends, you're loading your pump curves, how they're going against your pump curves versus, how the actual performance is going. This one is actually Andrew Harrison's graph. So Andrew spent a lot of time working on rainfall-dependent infiltration and inflow analysis. So that's just layering in different pump station activity and rainfall and using that to therefore work out where infiltration might be occurring within their catchments and then go and focus on smoke testing and the like. And what we also worked out in that discussion was, well, we've got the current data there and we can use that for, saying, okay, we're identifying where the issue is. But after we've gone and done smoke testing and identified, what it is, we can then go back and look at historical data to actually say, well, because part of what we do when we're doing infiltration is we'll go and fix it, but we don't know what the actual magnitude of fixing it was. So you can go back over time and go, well, we've got this rainfall event. We had the same rainfall event, 6 months ago, and look at that historical data and use that to work out the magnitude of your success of your programs. So you're actually starting to get insights into your activities based on the data that you've collected historically, as well as projecting forward. As ESC reporting, look, these were just some of the automations that they started to play around with. Priority 1, 2, 3 bursts, how we're going year to date, what's the performance targets like. You can see it's all about understanding data and actually utilising the data that we collect in more effective ways. When I set out at the outset about defining the problem statements around the big data and analytics or flagship program, the first question I asked everyone was, How many of you use an Excel spreadsheet to store your ESC KPI data? Now, the 19, there was 13 of them that all put up their hands. Now, if we're utilising an Excel spreadsheet, which is typically only one person can use, anyone can manipulate, what's that doing about those targets that we've set with and agreed with the ESC are meant to be about the performance of our businesses. So how often are we actually looking at them and interrogating them and the data that supports them to say how our businesses are performing? It's become a reporting task, not a business activity task, and that's what it should be about. And this was just another example. So Silbat data, you drop in, you get your acoustics, and nothing ever happened with that data. It was just a data set. The great thing about Pi is you can pretty much drop anything in there and then put it into some form of visualization. So this one was just a simple way of saying, this is the asset, this is upstream, this is downstream. So if there was an issue, oh, look, suddenly, and then you go, okay, well, if I take that data, and that's just a way of looking at the data, a different way of visualising it. And we've never had a way of visualising the acoustic data. It's just been collected. You know, you're out there, oh no, there's no blockage, it's clear. But over time you start collecting that. And then you can create a map like that, which says, okay, well, we were out there and we did our acoustics and that was all clear. Oh, but we had problems here and here and here and here. Oh, and guess what? Maybe what we do is develop a program out of that that actually triggers the way that we go and do our work. So suddenly, from data that was just collected and a tool that was being used in a certain way, and you go and put it on a map, and it changes the way that you look at it and the way that you act and the way that your business performs. And this is another example. This one's actually a Melbourne Water example of from their pump stations, and just being able to see, you know, how on this side, and it's just an example graph, but basically this is saying, you know, how much is being pumped at the various systems. So you can get a system-wide view and how much sewage is moving through your system based on if you've got a rainfall event, you know, you can see at the end, you can put multiple different sources of data all into one viewpoint. So it's about creating that access, it's about creating the opportunities for interrogation, it's about creating opportunities for insights and advancing the way that the analytics that we have about our businesses. The third trial that we had set up and went to investigation stage was with AECOM, and it was an asset management based trial. So, you know, they came in with the perspective that they'd completed the asset management customer value project for WASA. They had a number of insights from that, and they felt that by utilising those learnings and developing some systems, they would be able to help improve not only asset management, but the way that we use data and collect data for our asset management. So that was what we were looking for in this project. Spent a bit of time. They originally it started with Gippsland Water, and then some things come up there, so we ended up at Barwon Water, and with Gippsland Water and Western Port observing and providing strategic input to the process, and scoped out two projects. One was an asset renewals predictive community analytics tool that they identified called SEAMS, which is from the UK, and really powerful tool in terms of helping businesses prioritise between works that you would do for a maintenance perspective versus capital improvement type works. So it really, and then looking at the optimisation of those works so that you can influence the overall outcome of your business in terms of investment going forward. So if you're thinking water planning processes, if it's about how you align your customer performance, so you know, what's your levels of service that you define, the level of investment that you're required to deliver that level of service, this tool helps you do all that and prioritise between, okay, in order to maintain your assets, this would be the cost, but hang on, it might be better to do a capital investment here. So it's a prioritisation tool at the end of the day. And the other one they looked at was a SCADA integration with IoT data for failure prediction in pump stations and the like. So through that process, and the project ceased at the design phase because we looked at these two options and went, look, you know, the business case for that is not being supported by the data that we've put together. So all the time in IWN, the purpose of our vehicle, if you will, is about identifying potential projects, exciting opportunities for our industry, but also learning what doesn't work and then sharing that so that we don't necessarily go down that trail. What we did, the SCADA one, we went, look, realistically, Barwon felt they could actually go and do that themselves, so thanks for the idea. We'll go and pursue a project there. With the SEAMS one, we see it as a really valuable tool, but in the context that it was being applied, it wasn't stacking up as a return for the industry in that context. So what I did was turn around and said to Michael, well, look, from an asset management perspective, how about you guys have a look at this SEAMS product and see how that fits within you know, a potential trial. And so now, instead of focusing on a big data and analytics perspective, we've switched it around and we're taking it from an asset management optimisation perspective. And so Michael's leading that through his program now. So we'll look at a potential trial of SEAMS in the near future, I would think, and get some good opportunities out of that. The two businesses in the UK that used SEAMS as part of their water pricing submission were the two highest ranked in terms of the outcomes by their regulator. So there is some supporting evidence, and Icon Water have saved some significant dollars by utilising it recently in Australia, but they're keen to get some visualisation, if you will, in the Victorian market, and they want to be able to hang their hat on something, and I said, well, IWN's more than happy to negotiate with you on the best way to do that. And the other part about this trial, which has spun off and will be beneficial for IWN, was Deakin University was involved throughout the process, and they did some early work about digitisation. So they started to talk about, you know, what's the digital future for a water utility and the like. And now we're looking at a potential ongoing research project that would involve them and also WASA. So taking that digital utilities focus that WASA did, pulling in some of the stuff that we've learnt through this process, and then the people within Deakin to actually look at how we might do some trials or case studies around that. So that's where we're at with that one. So that's the flagship project or program, which Big Data and Analytics. You can see there's been some really useful insights. Now we've got to try and get that out. Obviously the Western Water trial is still occurring. I know a number of businesses are visiting Western Water and going to see some of the implementation there. And I know Dean's always putting up his hand to say, look, if anyone wants to come and have a look, come into our operations centre, see how it's working. And then the other, with the Lower Murray Water trials, we circulated the offer that OSIsoft put to the water businesses about licensing arrangements. So if we get a collective group together and get over $1 million worth of licensing arrangements across the state, we'll go to an enterprise arrangement and effectively mean that we have unlimited tags of data that we can load into Pi and also unlimited license access. So there's a real opportunity there. Now, having said that, it's still some high costs that have been put forward. We'll go back to Pi once we get a bit of a collective understanding of who's interested, and we'll have that discussion with OSIsoft about, okay, we're going to provide you with an opportunity to perhaps get into a broader market, which might be the state government via reporting through DELP. Here's an opportunity for us to talk about the colour of your money.